know if it's working. Test, 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 test. Better? Okay. Hopefully it's recording. It's been doing better. I didn't. I know for sure. I didn't hit partial. Okay. So get your whiteboards out. Okay. I need to move. There it is. All right, can you guys show me this on your whiteboard? If you're not, you should be using either a whiteboard that has a graph or you should be using one of those green ones so I can actually see it. Okay, can I see? Okay, we're having trouble over here. Okay, and here? Where's the graph? Look at his. Where's the graph, though? That's good. Okay, at least you got the starting point. Okay. All right. Okay. 5, 4, 3, 2, 1. Almost 100% understand that this is going to be a translation to the left 2, and this is going to be a translation down 3. We're doing good on that. So over 2, down 1, 2, 3. That was, for lack of a better word, would be my vertex, right? Squares, right? The square root of 1 is 1. And the square root of 1, 2, 3, 4. So the square root of 1 is 1. And the square root of 4 is 2. So I would go 1, 2, 3, 4, up 2. What would the next number be that I would use? 9. Because that's the next square. Right? If I did the square root of 5, would that work? 6, 7. It wouldn't be pretty. I could do it. It would just be it would be a fraction, right, or decimal. So this is my x value. This is my y value in a table. If you wanted to use a table, okay? Make sense? Hi. All right. So I'm going to erase this. We're going to do another one. Okay, show me that one. I'm going to pause it. Okay, these are looking much better. All right, so this is to the right, 1, and up 4. So we're going right 1, up 1, 2, 3, 4. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. Did that just click for some of you? Yeah? I kind of felt like their light bulbs went on. Okay. Fantastic. No, Bryce, this is the only difference, okay? If there was a 3 in front of here, I would multiply by 3. So instead of going over 1, up 1, I go over 1, up 3, and I go over 4, up 6, right? 2 times 3 is 6? Okay. Good question. All right. What about this one? Can we You guys do this one for me? The cubic function. Uh-huh. But we've been revisiting all of them, right? What do cubes look like? Show me with your hands. What do cubic functions look like? They look like this, right? Okay, put that at 16. Okay, can I see? Can I see back here? Okay, we're at about 75%. 5, 4, 3, 2, 1. So this is to the left 2. Okay, let's get our table of values over here. You guys do realize when I do this t-table, it's not the real numbers. It's not the real coordinates. It's just it's a transformation that I'm doing. Okay, I will explain. Okay. It's doing the problem as if I was right there. It's telling me where to go, but it's not the actual ordered pairs. But I'll show you how you can figure it out with the ordered pairs. So just hold on. Let me show you. Okay. It's like, you know what? I'm going to do this. Let's do this. You guys ready? Ethan, ready? I just hit the wrong button. I know I did. Did I? Oh, no, I did it right. Okay. So I'm ignoring this right here, right now. I'm ignoring that. I'm just talking x cubed. Right? Everybody with me? I'm at the origin. I don't have any type of shift. So if I put in 1, first of all, if I put in 0, I get 0, right? That's where I'm at right now. If I put in 1 and I cube it, I get 1. So I go over 1, up 1. If I go over 2 and I cube it, I get 8. So I go over 2 and I'm up 8. It does the same thing in reverse. If I put a negative 1 in and I cube it, I get 1. And if I put a negative 2 in and I cube it, I get 8. Thank you. Negative 8, negative 1. Thank you. All right. So that is our cubic parent function. Correct? Now, do our magic, our whiteboard magic. So all I'm doing when I look at this transformation is I'm taking it and I'm shifting it over 2. That's it. Okay? It's the same thing. Well, but do you see that now these points are not my ordered pair anymore? I'm not at 0, 0, right? I'm shifted over 2. But you could use a table of values if you wanted to. I could use a table of values with this right here. I would just say I've got, if I wanted 0, I would take 0. I would add 2, right? And then I would cube it. Does that make sense? So if I have 0 plus 2 is 2 cubed is 8. So that's the point. When I put in 0, I get 8. When I put in 0, I get 8, don't I? So when I'm over here using these numbers, I'm working off of my new vertex. I'm going over 1, up 1. I see no need to plug values into there when I can just work off of the vertex. Does that make sense? Okay. Yes. 0. If I plug in 0 for x, I get 8. 0, 8. I'm just going to confuse you guys by doing that. I'm trying to show you an alternate way of doing this by using a table. Okay? I'm no longer going to do it because I think it's just going to confuse 50% of you. Yes, Malik? No, I don't like this. I think this is more tedious than just understanding what the parent graph looks like and knowing that you go over 1, up 1, over 2, up 8, right? Isn't that a little easier than plugging a bunch of values in a table? Because the reason I don't teach, this is old school way of doing it. This is more Common Core of doing it. The old school way of doing it, in my mind, has more room for error, right? You can make calculation errors. I'm not going to make any calculation errors by going over 1, up 1, over 2, up 8. There's no calculation to it. Do you know what I'm saying? Okay, that's why I don't teach it this way, but I thought maybe it might help some of you. All right. But I think I'm just making it a little bit more difficult. Okay, show me that one. Yeah, you just go over 1, up 5. Okay, show me. Nope. Jay, I need you to put your head up, please. Okay. No, not a lot of people have different things. Okay. 5, 4, 3, 2, 1. Okay, so this one is over to the right 1 and up 5. So we're going to go over 1, up 5. 1, 2, 3, 4, 5. My magic numbers, my reference points are over 1, up 1, over 2, up 8. Over 1, down 1, over 2, over 2, down 1, 2, 3, 4, 5, 6, 7, 8. Think you were, yeah? I think we're doing good. Over 2, down 8. Because I did. I went over 2, but it's off the graph, so I just. It's the same points over and over and over again. For this one needs 5, right? Because it's got one direction that has 3, and it has another direction that has 3, so it has 5 points. Unless there's a stretch. I don't normally do the stretch. Why would I not normally do ones with stretches? Because it'll be way off the graph, right? Right? It would be way off the graph, but I'll show you one. Okay, so here would be one. We'll do something with a 2 in front of it. So f of x equals 2 times x minus 3 cubed plus 1. So I'm going to go over 3. 1, 2, 3. Up What? Gosh, thank you, thank you. 1, 2, 3, plus 1. So there's my vertex. I'm going to go over 1, up 1, but instead of going over 1, up 1, I'm going to go over 1, up 2, because it has a stretch. If I put in 0, I'm going to get 0, right? But if I put in 1, normally I'd get 1, but I'm going to multiply it by 2. You could. That's a good way of putting it. 2x's, yeah. Gets me my y instead of just 1x. And then I would go over 2 and up how much? 16, which is way off the graph. Over 1, down 2, over 2, down 16, way down here. Whoa. What just happened? Thank you. Better? Okay, we got to move on. Okay. It's the same thing. It's reflected, right? It's the inverse. So what points do you use? Is it all clicking? It's on it's reflected. Okay. So when I put in 0 and I take the cubed root, I get 0. When I put in 1 and I take the cubed root, I get 1. What's the next number I'm going to put in? 8. And 2, it's the x and y have been switched. That's it. Right? No, not with cubics. Cubics, you can write the whole thing because it doesn't. It's not symmetric. Yes, Aaron. So for a square, we didn't have line going in one direction. We didn't have it going the other way as well. Because it wouldn't be a function. It wouldn't be a function. So what about this cubic root? Cubic root will be a function because it's not a reflection. Yes, essence. No. You don't have to do the chart at all. Okay, so I'm going to go to the left one, right? And I go over 1, up 1, over 8, 1, 2, 3, 4, 5, 6, 7, 8, up 2. Over 1, down 1, over 2, sorry, over 8, 1, 2, 3, 4, 5, 6, 7, 8, down 2. The points, if I were to do this, would be here. Oh, up 1, over 1. It's a parabola on its side. That's what it is. It's a but it's not a function, so we only do the top part. We're going to talk more about that today. That's a good question. Yes, it would be wrong. Okay. So you guys ready to do this other one for me? Okay, show me. It's the same thing on its side. The points are just transposed. All the points are just transposed. That's it. I mean, you're going to see pieces of this in math analysis. This is your foundation for math analysis. Yes, Malik. It just on what you prefer. It just depends. Some people don't like stats. It's very if you have that mathematical mind, some of you would much prefer math analysis. Okay, can I see, please? Okay, and here? We are looking good. Except the other on the side. Good job. Okay, 5, 4, 3, 2, 1. So I'm going to go to the left 5 and down 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Up 1 over 1. Out 1, 2, 3, 4, 5, 6, 7, 8, 2. And this other one's not going to fit. Okay? Good. All right. Okay. We're almost there. Okay, so check this out. This is the only new material that we're doing. So I have, this is going to be shifted to the right too, correct? It's a parabola. So parabolas are over 1, up 1, over 2, 4, right? 1, 1, 2, 4. 1, 1, 2, 2, 3, 4. 2, 1, 2, 3, 4. I was a little disappointed in your graphs on your polynomial, no, your rational function test. I finished grading them last night. They'll be in tonight. And I was disappointed because your parabolas, a lot of your parabolas didn't look good. You should know how to graph a parabola. True graph of it is a sketch. This is a sketch. You should have these 1, 2, 3. You should have those 5 points for a parabola. As long as I saw the 5 points, to me that's a correct parabola. Yeah. Okay. So I'm only talking about when x is greater than 2, though. Why would I care about when x is greater than 2? There's a reason. Yes, but why would I care about the restriction? Let's hear it, Nick. Okay, you guys are doing real world, and I guess I'm just not answering it correctly. You're right, but I would care about the restriction because when we're talking about the inverse, it's only going to have half of it, right? So on this one, I'm graphing when x is greater than 2, because this is where x is 2. This part is anywhere, this is 1, 2. This is where x is greater than 2. I'm only going to concentrate on the graph when x is greater than 2. If this said x minus 3, I would talk about x being greater than 3, right? So the other one is just the other side. The other one is just the other side. So it's the same thing, right? Only I'm talking about when x is less than 2, so I'm talking about the left side of my parabola. Exactly. We're almost ready. Okay. Now I'm going to graph each inverse. Okay. The inverse is reflected over y equals x. So check this out. How do I find the inverse? I'm going to take these points, right? Or I can take the equation and I'm going to switch x and y. Correct? So when I switch x and y, 2, 0 is going to become what? 0, 2. Does that look like it crosses over, reflects over y equals x? And then 1, 2, 3, 1 is going to be 1, 1, 2, 3. Do you guys see that right now I have the beginning of my square root function? Do you see it? So instead of going over 2, I went up 2, correct? And I'm still doing 1, 1. What's my next number going to be? 2 and 4. 1, 2, 3, 4. Oops. 4, 2. Right? It's 4, 2. I'm going to go over 1, 2, 3, 4 up 2. Because it's the inverse. So this is what we're doing today. So this one, right, instead of going over 2, I'm going to go up 2. But instead of going up 1 over 1, I'm going to go down 1 over 1. 1, 2, 3, 4, down 2. Does that look like it reflects over the y equals x? So that's what we're doing today. No, you don't have the homework already. Okay. I'm going to show you how to do it formally. So this is what we're doing, inverses, squares, and cubes. So the square is the square root, and the cubic is the cube root. Okay. I'm going to do this super quick, and I'm going to give you your homework because I want you guys just to work on it. All right. So g of x is graphed for us. It is a parabola, but it's shifted down 4, right? It's a parabola shifted down 4, and I've restricted x has to be greater than 0. I only have the right side of the parabola, the positive side of the parabola, right? So I know my inverse. What's my inverse going to look like? What shape is it going to be? It's going to look like this. So this one I knew was going to look like this. This one I know is going to look like that because it's going to be the positive side of a radical function. All right, so how do I get it? How do I get its equation? I switch x and y. So this is actually y equals, I'm going to change my color. This is y equals x squared minus 4. If I switch x and y, I now have x equals y squared minus 4. How do I get y by itself? Add 4 to both sides, so I get x plus 4 equals y squared. How do I get rid of a square? I do the inverse, which is square rooting. So I square root both sides, and I get g of x equals the square root of x plus 4. I know how to graph, right? I know how to graph x plus 4. X plus 4 is to the left, 1, 2, 3, 4. I don't have any type of stretch, right? So I know my magic numbers are what? 1, 1, and 1, 2, 3, 4, 2. And that's it. There is the inverse function of g. Okay? One more? Let's see. Hold on, I want to show you. Okay. So here is, now I have g of x is a square root function, a positive one, right? So what do you think my inverse function is going to look like? It's going to be, what's the inverse of a square root? Squared, but since I began with a function that only had a domain, or it doesn't even, it only has the top part, not the bottom part of the sideways parabola, I know that my new one is only going to be half a parabola. Right? Because if I switched each one of these points, wouldn't I only have half a parabola? I don't have the other side of the parabola. So, let's do this. I'm going to have, this is y equals the square root of x plus 1. I'm going to switch x and y, or transpose x and y. So this is x equals the square root of y plus 1. I'm trying to solve for y, so I'm going to subtract 1 from both sides. How do I get rid of a square root? I square it, and I get y equals x minus 1 squared. But I'm only going to have half of it. It's not x minus 1, x plus 1. It's just x minus 1 squared, which is x minus 1 times x minus 1. Okay, so we're going to go to the right one. And since it's a parabola, it's over 1, up 1, over 2, up 1, 2, 3, 4. I'm not going to do the other side because I only get the positive side of it. Yes? I think on the homework I say, so the restriction would have to be x half greater than or equal to what? 1. It's shifted over 1. Right? X, only the top part. Ready for homework? Okay, I'm going to give you your homework, and then I'll go through more examples for some of you. This is number 4 in your homework, so you can go ahead and copy it down. And the homework I'm about to give you. Let me pause this. All right, actually, I think, let's do this one. 7. So 7 looks like this. So its inverse is going to look like this, right? I'm going to transpose x and y. So right now, y equals x cubed plus 2. But when I transpose it, it's going to say x equals y cubed plus 2. I'm going to subtract 2 from both sides. And now I have y cubed. I don't want y cubed, I just want y. So I take the cubed root of it. Cubed root, and then left with y equals the cubed root of x minus 2. Therefore, my inverse function is cubed root x minus 2. Cubed root x minus 2 is shifted to the right 2. My magic numbers are over 1, up 1. Over 8, 1, 2, 3, 4, 5, 6, 7, 8, up 2. Down 1 over 1. Over 1, 2, 3, 4, 5, 6, 7, 8, down 2. Does that look like it's the inverse? Here's how you can tell if you're right. Test a point. Here's a point. Over 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 10. So what should my inverse be? 10, 2. Over 10, up 2, am I right? That's how you can tell if you're correct. Some of you on the test will try and just take the points and switch them and not do this. You need to be able to do this as well. Okay? Make sense? You can just do that. I could graph every single one of these by just switching x and y, the points, right? But you have to be able to do it algebraically as well. Tomorrow. All right, have a great day, guys.